Hello viewers, welcome to this video lecture series on computer networks. Actually this particular session belongs to both theory as well the networks lab. So in this session I have decided to make you get complete knowledge of IPv4 addressing. So here my method of carrying out this particular session is, let me start with the very few basic things of IPv4 addressing. Then I will start telling you mainly what most of the time in the theory a question is asked on subnetting. In the lab experiments, you are making so many network scenarios, you are setting up so many networks using the simulator like Cisco packet tracer. So there you have to know how to assign IP addresses to each of the devices, because definitely a network is made up of devices, whether it is an end device or it is an intermediate device. For each of these devices you are supposed to give what an IP address and subnet mask. So since you have to have many number of networks in an experiment, normally in an experiment will start with a very simple, like just with one network. Then we will try to see that how you connect one network with another network. Then we'll see that there is a third network existing in between first network, middle network and the last network. So when you have number of networks, so we have a practice of giving the IP addresses belonging to different classes also. Like we want to give class A IP address and subnet mask to one type of the first network, then class B to the second or the middle, and like this for each of the networks which you are going to set up in the simulator or in any actual physically. If you are constructing the particular experiment, then you have to know how to assign IP addresses. And in theory, in the examinations, most of the time a question is asked in this manner, like even in any IP. That means in the question an IP address will be given, and you will be asked to find out the class type. Then that means to which type this particular IP address, to which class this particular IP address belongs to. The subnet mask you need to find out, number of networks that are possible there, number of actual networks. Okay, I'll tell you the difference between number of networks and number of actual networks. Then number of IP addresses and number of usable host. Okay, and once again here also I'll tell you the difference between these two. Then you need to find out the network address and the broadcast address. So almost if you see, there are 8 different components you can determine from a given IP address. So in order to carry out the solution for this type, I have made it in a very simpler form. You can always carry out these type of questions very confidently if you remember these tables. Very simple information in a simple manner I have put here in the table. I have made 3 tables here. In one table itself you can include the contents of the second and third table also in the very same first table only. So what exactly here you are going to do? Before that, let me just introduce this particular topic, because already I have done this in my theory sessions also in computer networks theory series. The introduction to classful addressing and classless addressing, that is class A, class B, class C, everything I have mentioned in detail in my video sessions in theory series, that is computer networks video lecture series. So you can definitely watch that. That is lecture number 7, 8, 9, 10. Okay. So you can watch these video lectures to gain the knowledge which I have given in detail there. But in this video, I'll be summarizing those things as well. Okay. And so that you'll be able to carry out this numerical very confidently. So before I start teaching the solution how to carry out, I'll just make you recall first the concept of IP addressing. Then I'll explain the contents here in this table. Then I shall move on to this. And it is not just the first experiment. I'll give you the guarantee that I will cover all possible types of questions on this type. That means given an IP address means address can be of class A, class B, class C, or once again an address can belong to a classful addressing also. So I'll cover all possibilities of a numerical that can be asked on this particular topic. So let me begin. First and foremost thing is, okay, you are using the devices. So already I have told in my video, it can be an end device or it can be an intermediate device. Let it be any device, intermediate or end device. For each of these device, you need to give what? You need to give an address. Any device which you are using, okay, will have 2 different addresses, 2 types. One is called as the logical address and the other is called as the physical address. Logical address and physical. So example for the logical address is an IP address. The physical address is MAC address. In IP address, you have IPv4, that is the version 4 and version 6. Fine. So here it is only one type, it is a MAC address. Okay. Now this way you try to remember the flow from the different, the flow for the addresses, and here 32 bits are meant, okay, or to denote an IPv4 address. Here 128 bits are used for an IPv6 address, whereas MAC address is how many bits? 48 bits are used here to represent a MAC address. 32 bits are used to represent an IPv4, 128 bits are used to represent an IPv6, and 48 bits are used to represent a MAC address. Now this device, let it be anything, I said no, let it be a desktop or a mobile phone or laptop, anything. Now suppose you are having the laptop, definitely all of us have got the laptop or the mobile phone. For each of this you can check the MAC address and the IP address that is assigned to your device. For this also I have already recorded the sessions and posted in my video lecture series on Computer Networks Lab, and I can tell you the lecture number. So lecture number 8, lecture 10 in Computer Networks Lab series is about the MAC address. Actually the heading is NIC, Network Interface Card. So on this network interface card will be printed a 48-bit MAC address. So that is the physical address for the device. But as long, see, physical address is sufficient only when you are able to communicate in one network. Suppose if you want to communicate from one network to another network, then you require a logical address. And logical address is what? IPv4 address or IPv6 address. So that is why whenever we have an internet connection, we get an IP address from our internet service provider. If it is an Airtel, we are getting an IP address. If it is Jio, Reliance, whatever it is. From these internet service providers, we are getting the IP address. And also in my video lecture, in lecture 10 of a network interface card, I have mentioned how to check the MAC address of the device. So MAC address we can manage only if we are, suppose if this is a LAN, and you know very well, in the LAN you require what component? The switch component if you want to connect more than 2 PCs. So if you want to connect more than 2 PCs, you require a switch. Fine, because I clearly told you in my previous session also, 2 PCs can be connected and communicated. Because more than 2 is not possible, you require this device switch, okay, to make all the PCs get connected in your network. This is called as the local area network. Now if this PC wants to communicate with this, or this one with this, or any device with any PC with any other PC, MAC address is sufficient. Fine, MAC address is sufficient for these PCs to communicate with each other. But the moment this network wants to communicate with another network which is also having different PCs connected, fine, through a switch, so this is what? A second network. Then what will happen? First and foremost thing is to communicate, to have connection between these two networks, we require another intermediate device called router. So this also I have a video session completely on this device router. So when a particular PC, okay, PC4 wants to communicate with another PC, PC8, that time this MAC address is not sufficient for this PC to communicate. It requires another address called as the logical address. Hope you are getting this point. Why logical address is needed for a device? As long as you are in one network, one local network, all devices can communicate with each other just with the MAC address. That is the 48-bit physical address that is there, or that is printed on the network interface card. But the moment you want to communicate to another network, okay, which is connected via a router, that time you require a address, and we call that address that address as the logical address, and we are using the IP addressing mechanism. And in IP we have two different versions, version 4 and version 6. For carrying out all the experiments in the lab, we are using the IP addresses belonging to which category? IPv4 addressing. So that is what is the heading I have mentioned here, IPv4 addressing. So let me just briefly tell you about the contents in this table, then the procedure to solve a numerical of this sort I'll explain. So what exactly are the contents that are there in these three tables? Actually you can club, as I said, all the contents and put it in one table only. Since I wanted to use the other part of the board, so I have placed like this, one below the other. First thing, so hope you people will be able to recall IPv4 addresses. Okay, IPv4 addressing concept. 32 bits are used to represent an IPv4 address. 32 bits here, if I have to write in binary, suppose if I am writing a combination of ones, zeros, zeros, ones, zeros like this. So what, up till how many? 32 bits are here, okay, binary. Now 2 to the power of 32, you just see the number, it is around 4 billion. 4 billion IPv4 addresses are possible. Now, because it is such a huge number, 4 billion, and it is very difficult to manage the addresses, that's the reason the complete 4 billion addresses are divided into 5 classes, and that is called as class A, class B, class C, class D and class C. Now if you look here, this 32 bits, if I put the very first one 000, okay, all the last one will be what? 111, 111. So this will be your first IPv4 address and this will be the last. In between you have so many, or from this which category? From the 4 billion, that is complete set of IPv4 addresses. This will be the first address and this will be the last address. It is difficult to express the IP addresses in binary form. That's hence what we do is we always express the IP addresses in the form of decimals, and we call it as a decimal notation. Okay. So binary notation is very difficult to express every time. If there are 32 bits here, I can divide this 32 bits into 4 sections. Okay, into 4 sections. So first section will have 8 bits, second section will have 8 bits, third section will have 8 bits, and fourth section will have 8 bits. So now if I have to write this in the form of bits, 8 bits is what? 1 byte. Fine. Then what I will do is I will divide this IPv4 address into 4 sections, each consisting of 1 byte information, 1 byte, 1 byte. Okay. So this 8 bits only is becoming now what? 1 byte. Now normally we call a set of 8 bits as octet. So there is one octet here, second octet, third octet and fourth octet. Now in this way we can represent what? The binary numbers. Now there is a possibility, in the first byte all possible zeros can be there. Fine, all 8 zeros, or the maximum value will be what? 1 1 1 1 1 1 1 1. So these are the minimum and maximum binary values in each octet. Zeros, all zeros or all ones. Now when you convert this all zeros and all ones into decimal, then what is that you will be getting? The binary, the decimal notation of the first IPv4 address will be 000. That means 0, we always have we call this as actually dotted decimal notation. So you have to separate each byte with dot. So 0.0.0.0. And the maximum address will be what? The last 255.255.255.255. Fine. So that means here in each octet, there can be what? A minimum value of 0.00000 So all 8 zeros. So like that, this may belong to here. There can be a possibility of all ones, and that can be what? The equivalent decimal value will be 255 for this all ones. So that means what? This octets, whatever you have here, it is easy for us to express in dotted decimal notation. That's the reason we always use the dotted decimal notation here in our examples as well, what to explain the concept of IPv4 addressing. Now let us see. So that's the reason what I have done is I have written the decimal numbers range here in the classes, the different classes. As I said, IPv4 can have what? 5 classes, because it is very difficult to handle completely more than 4 billion addresses. All those addresses get divided into 5 classes. Class A actually has got 50% of the IPv4 addresses. Class B is having 25%, Class C 12.5%, Class D 6.25% and Class E 6.25%. So this way all these IP addresses are getting divided. What can be the first byte range here? The first byte, see when you have these bytes, okay, when I am writing this in the form of decimal, Now I have shown you what can be the minimum values in the binary and maximum values in the binary in each octet. Similarly, the minimum and maximum in each octet in the decimal. Minimum can be 0, maximum can be 255. Minimum can be 0, maximum can be 255. Minimum value can be 0 in decimal, minimum 0, maximum 255. Okay. So if you want to represent an IPv4 address, always use the dotted decimal notation. So you can always remember the table contents in this manner. Given an IP address, you just check the first byte. And suppose if you are writing the class A address in binary, the first bit will be, okay, let me make a correction here. It is 0. The first bit will be what? 0. So always class A addresses begin with 0 and the equivalent decimal value will be 0 only for the first IPv4 address in the first octet, and the maximum value will be 127. So I need to say with that table, suppose if you have 4 octets, fine. Always given an IP address, you can determine the type of the class by just checking the first byte. So this is your first byte, this is your second, third and fourth. 4 bytes are there, no? So in each of this, in class A, what, no? The first byte is always ranging from 0 to 127. And for class B, it is ranging, I have mentioned there, 128 to 191. And in class C, it is ranging from 192 to 223. And in class D, it is ranging from 224 to 239. And in class E, 240 to 255. Okay. This way, this is the first bit. Now, no need to worry about the second, third and fourth. Suppose if they give an address like 192.168.16.24, just these are the 4 different decimal numbers. That means the values in each of the octet. Now, what is the first byte number? 192. Look here, 192 means it lies in the class C. So we can easily say that this address is belonging to which type? Class C type. So this way you have to just check the first byte number and find out to which particular class this IP address belongs to. That's the reason I have written here, given an IP address, you are asked to find class type. So this is how you have to find out the type of the class in this manner. So hope this is what are the contents. You have to remember this. And next is what? Also you remember the starting binary numbers for each of these 5 classes. The reason is with this binary numbers only, whatever are these binary values, zeros and ones, the starting numbers, with that we can actually find out how many number of networks possible. Normally by default, so I'll make you recall this point also so that it is completely covered in one session itself, the complete information. Now, always for networking lab, we are using addresses from these 3 classes only, class A, class B and class C. So in every class, out of this 32 bits, okay, 32 bits, some bits are meant for the network ID and some bits are meant for the host ID. That means what? You have a network, okay, network A, and in this network are connected what? The different hosts. How many hosts? Let me give one simple example. 4 hosts are there. So some bits are used to represent the network ID and some bits are used to represent the host ID. So this way the network ID and host ID are the 2 different components of an IP address. Now in class A address, what is happening is class A address, 8 bits are used for the network ID and 24 bits are used for the host ID. See, this is what I have written here, the table. So no need to once again write here. Look at this contents. Out of these 5 classes, normally we are using addresses belonging to what? 3 classes only. Class A, Class B, Class C. Class D is multicast addresses and Class E are reserved for future use. So only these 3 classes, addresses belonging to these 3 classes are used. So what is that I have mentioned here? Out of 32 bits, 8 bits are used for what? The network ID in class A and 24 bits are used for the host ID. What about class B? 16 bits are used for the network and 16 bits are used for the host. And what about class C? Class C, 24 bits are used for the network. Okay, let me write it. 24 bits are used for the network and 8 bits are used for the host. 8 bits here what is that? 24 bits. So this part, okay, this whatever is the network part is called as the net ID. Here it is called as the host ID. Similarly, here network ID, host ID. Network ID and host ID. So you can always see when you add up 8, 24, 16 plus 16, 24 plus 8, it is making to 32. So this way the network part and the host part is there. Now apart from that, you should remember the subnet mask for each of these classes. Since you are using class A, class B, class C, what are the subnet mask? And first of all, what is a subnet mask? Subnet mask is a 32-bit number which is going to clearly distinguish between the network ID and the host ID. You will clearly get to know the network ID's part and the host ID part from the subnet mask. Because you have in class A 8 bits meant for the network, that is why the maximum value, if you write here in dotted decimal notation, the first byte number will be what? 255. And the remaining 3 will be what? 0000, because host ID network, because what we are going to tell in the subnet mask is how many bits are meant for the network ID. We keep only 8 bits as the network ID in case of class A. So when you are writing 8 bits in the 8 bits are used. So what will be the decimal equivalent? 255. What about the other 3 sections? Other 3 octets are all belonging to host ID only, and that will be 0000, because we have to mention here only which the network part of each class, and the network part of each class we need to denote it with what? 1111, and that is how we are writing here the default subnet mask. I'll repeat this. Subnet mask is what? It is a 32-bit number. Now this is the subnet mask, default subnet mask for the class A. It is a 32-bit number which clearly distinguish between what? Which will clearly distinguish between the network part and the host part. The network part is always represented in terms of ones and the host part is represented in terms of zeros. Okay. So here you can see this octet and this octet, fine. This way you are writing what? The default subnet mask for the class A. Why did you choose 255.0.0.0 for class A? Because 8 bits are meant for the network part. Similarly, for class B, 16 bits are meant for what? The network part, and 16 bits are meant for the host part. So 16 bit means 2 bytes, it is covering 2 bytes. Will be all ones in case of class B. So 2 bytes, 2 octets will be 255, and the third octet which is representing the host, and the fourth octet is also representing the host. So this way this is for the class B. And what about class C? Class C is having 24 bits for network part and 8 bits for the host part. So that means now for class C, 3 octets, okay, 3 octets will be what? 255, 255, 255. Which is representing the network part, and the host part, as I said, will be denoted with zeros. So this is how the default subnet mask for each of the classes will be mentioned here. So hope with this introductory part you can start working on what the solution to such kind of problems. Let me take one example first from class A itself, find out all these things, then we'll move on to class B, class C. And in addition to the previous information, remember one more point, the network, okay, the network part is always called as the prefix and the host part is always called as the suffix. As I had given in the previous example, if this 8 bits are there for class A and 24 bits are there for 8 bits for the network, 24 bits for the host in class A. Okay, so this 8 we call it as prefix, okay, this network ID, and this 24 bits we call it as suffix, which is what is that? Host ID. So prefix and suffix, these two terms also you need to remember, because sometimes in the question they may use the word the prefix value is so and so, the suffix value is so and so. I have just written in general given an IP address. Now let me give one IP address, that is 10.12.16.32. So I have decided I will give this address 10.12 10.12.16.32. Fine. And you have one more method of representing an IP address using the slash notation. What is slash notation? Write down the IP address first as it is, put a slash and write down the prefix value. Prefix value, as I said, is what? It is always what? The network ID of that particular IP address. And the network ID is always used here in the prefix value with a alphabet called as n. Okay, n equal to 8, n equal to 16, n equal to 24. That means in class A, class B, class C, these are the values for the n. N is what? N is prefix. So sometimes they may give directly the prefix value also here, which is easy for a student to immediately find out to which class this particular IP address belongs to, because you always know that the network ID part is 8 bits. So here itself it is mentioned, we can find out, but always have a practice of checking the first byte to find out the type of the class. The reason I'll tell you at this point, if 8, 16, 24, if these numbers are mentioned here in the slash notation, then it is very easy to find out the type of the class. But suppose if you get some numbers which are not like 8, 16 and 32, then you must be wondering why it is apart from 8, 16 and 32. That is also a possibility here in the slash notation. So that's the reason always have a habit of checking the first byte number to determine the type of the class. So if there is an IP address with a slash notation and the value for the prefix is not 8, 16 or 24 other than these three, so I have decided I will teach you one example of such kind. Now let us take this example, 10.12.16.32.32/8. So the very first thing what you are supposed to do is to find the class type. How do you find the class type? Given is 10.12.16.32/8 is the IP address. So just check the first byte number here, and the first byte number is 10. 10 falls in this range 0 to 127. So you can write down the class type as what? Class A. This IP address belongs to class A. What is the subnet mask for this IP address? For class A, and also default subnet mask only you are going to write here. Anyway, you have seen that the number of bits, the prefix value is 8, and if there is a prefix value 8, the default subnet mask for class A will be what? 255.0.0.0. So this also you could find out easily, and this also, the second one. Third one is number of networks. How many networks are there in this particular, but with this address can you determine? Because definitely you have already determined that it is a class A address, and in class A you know very well that 8 bits are meant for the network part. Okay, net ID is 8 bits and host ID is 24 bits. So how many networks are possible? Just check the 8 bits here. Fine, 8 bits are there. Then 2 to the power of 8 is what? 256. 256 networks are possible here. One more thing they have asked is number of actual networks. How to find out the actual networks is always see the first number. Okay, 1 bit is always representing what? The class type. So excluding that, because as I said, suppose if the given IP address is mentioned in binary notation, the first byte is always denoting the class. If any binary IP address starts with 0, it is a class A address. If a IP address in binary notation, if you see, it is starting with 10, it is class B. If it is starting with 110, it is class C. If it is starting with 1110, it is class C. And if it is 1111, it is class C. So for actual networks, very simple, the remaining are there 0101, something like this. Okay, if you are excluding this first byte, then the remaining will be how many? 7 bits out of 8 bits, and 2 to the power of 7 will be how much? 128. So that is why we say that the number of actual networks are 128, but since 8 bits are used to represent the network ID, 256 networks, actually 128 networks only can be formed here in this class A. Fine. So this also you could find out. What about number of IP addresses? How many IP addresses are possible? Always IP addresses is what? Number of host only. Okay, number of host. Because now in class A, what is that finally I can give you with one example like this. How many networks are there? 128. Fine. if this is 0, if you are giving the network number with 0, 1, 2, 3, 4, 5, 6, 7, 8, the last network number will be 127 because 128 networks are there in class A. Now in each of these networks, what you will be having hosts, different hosts. Fine. So how many hosts are possible in each network? That is represented with the number of bits here in the host ID part, and it is how much? 24 bits. So you can easily find out number of hosts that are there here. Because 24 bits are meant for the host part in class A, you can easily write like this. For which one? This is for the fifth one, number of hosts, 2 to the power of 24. 2 to the power of 24 hosts are possible in each network. In class A, you have actually how many? 128 networks, and in each network 2 to the power of 24 hosts are there. And 2 to the power of 24. So these many hosts are possible. But what they have asked is number of usable hosts. What is the difference between total number of hosts and usable host? Always any particular network, class A addresses, number of actual networks possible are 128. So if 128 networks are there, for each of these networks, suppose if here there is network 1, network 2, network 3, like this, up till how many networks? Network 128. In each network, what exactly is happening is, if you have that these many hosts, these many hosts are there in each network, the first host is always what? The network address. The first address is always representing the network address, and the last address is always representing the broadcast address. Now the first address will not be assigned to any host, and the last broadcast address will not be assigned to any host. So in between are how many? That means leaving this and this two addresses, the remaining addresses will be what? The usable host addresses. So you can easily write in this manner the sixth part, number of usable hosts. Number of usable hosts. Whatever host you got here, okay, that minus 2. So it will be how much? 2 to the power of 24 minus of 2. Fine. That is nothing but what? 167777 2 you reduce, just 214. Okay. So you will be having these many hosts, okay, in each. That means usable host. Usable host is what? To a particular device you can give an IP address. But whenever you are giving an IP address to a device, you cannot give the first address of the network, you cannot give the last address of the network. That's the reason. Just subtract 2 from this total and you will get the number of usable hosts. And then you need to find out the network address and you need to find out the broadcast address. Now, how to find out the network and the broadcast address? Seventh part is the network address. How to find out what is the address given? 10.12.16.32. And we know that in class A address, already we have determined that this is a class A address. Network part is only what? The first 8 bits. So the remaining is what? 000. Very simple. To get the network address, write only the first byte 10 and the remaining host, which is having what? How many? 3 bytes, you make it 0. Okay. This becomes your network address. And also the network address will always be what? The first address. So you can always see that sometimes what they write here as to determine the first address. First address and network address means one and the same. Next comes the broadcast address, and broadcast address is what? The number of host bits should be converted to ones. So when you are converting the number of host bits to ones, what will happen? See, in the network address you are writing all the host bits. In the network address you are writing all the host bits as zeros, and in the broadcast address you will write all the host bits as ones. When you write all these 24 bits as ones, the equivalent decimal value will be 255. So your broadcast address will be, and broadcast address is also what? The last address in the network. So your broadcast address will be what? So this is the 8th part, okay, 8th component asked, and this is 10.255.255.255. Since from the beginning they have in the question itself it was given in slash notation, so you should also write here /8/8. So you are telling that this is the network address or the first address, this is the broadcast address or the last address. So this way you can determine the network address. So very simple way to find the network address is simply put all the host bits as zeros, and for the broadcast address put all the host bits as ones. Since this is a class A, you have kept all the 24 bits as zeros for the network address, and you have kept all the 24 bits as ones for the broadcast address. This is how you need to solve a numerical on this. So very simple. First thing is always check here the first byte to determine. I'll just repeat: to determine the first byte you need to check to find out the type of the class. Then subnet mask you can easily find out, because number of bits that are used to represent the network is what? The subnet mask. If in the question it is given, then it is very clear also here 8. So it is the subnet mask will be 255.0.0.0. Number of networks and number of actual networks you can always remember with this column. See, if every column information is actually helping you in solving one or the other component of this particular problem. If it is type of the class, you are going to check this column. So just check the first byte number and find out the type of the class. And next, when you want to check the subnet mask, look here, this table will help you. Number of bits that are used to represent the network ID will always give the subnet mask. Number of networks, how to find out? Always check here the network ID, this column of the second table, because you have the network ID as 8, okay, number of networks, network ID as 8, 2 to the power of 8 is 256, so you can easily find out the number of actual networks. You are just now remember this column contents will help you. The first bit is 0 here, exclude one bit and then make it 2 to the power of 7, you will get 128. 128 actual networks are there. Then next, number of host, this column information will help you. So the very first, so you can see here 24, 2 to the power of 24 is this much. These many hosts are there, but number of actual host or usable host will be always -2, because you have to subtract what? The network address and the broadcast address. So this way, and then finally you need to find out the network address and the broadcast address. Network address, always remember all the host bits you have to keep it as zeros, and for the broadcast address you have to keep all the host bits as ones. So this way you have to solve the numerical, and I shall continue this particular topic in my next session by taking an IP address belonging to class B, then next class C, and also I'll try to see that I'll give a prefix value other than 8, 16 and 24, so that you will have the confidence to solve these kind of numericals. Hope this session is useful to you all. If you find this session useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.